All right, before we discuss about the digital signature verification process, I would like to discuss about this key property of asymmetric cryptosystem, which makes this digital signature signing and verification possible. Now, assume that you are given a pair of public key ENN and private key D. You can compute X by using one of the key, either private key or public key, as follows. So here I'm using E to compute X over Y. And this key property of asymmetric cryptosystem ensures that if you want to get back Y, you can get back Y when you use the other key that you didn't use here. Okay, here you use E. That means if you want to get back Y from X, then you take X, here, and you take the other key that you didn't use here. So in this case, it is D because here you use E, right? Then you take X, then raise to the power of the private key D, and if you take modulus N, then you get back Y. And that is the key property of asymmetric system. Asymmetric in the sense that if you have used one of the key to compute something over something, then you can get back that something by using the other key that you didn't use. And you may recall that the first process is called asymmetric encryption, which we have discussed this when we discuss about confidentiality lecture. And the second formula is in fact decryption process, right? And at this point, you might be wondering, why are we talking about encryption and decryption instead of talking about digital signature signing and verification? We are talking about this because both digital signing and asymmetric encryption relies on this key property of asymmetric cryptosystem, and digital signing and verification is simply the opposite of this encryption and decryption process. But although in signing and verification, we do not use the term encryption and decryption because digital signing is about signing. You are signing a signature simply, and you are verifying the signature. So don't forget, we do not use encryption and decryption terminology when we are talking about digital signature, signing and verifying to ensure the property of the data in transit. All right, so signing is as follows. So similar process, instead here I'm using the actual value to compute things. We have to take the hash of M. This is how you read it. You take the hash of M, raise to the power of D, modulus N, then you get this signature. Intuitively, to get back this H and M, hash of M, so to get back this one, simply what you do, you take this signature here, and then you use the other key, which is a public key, because here, for signing, you have to use D because you are supposed to use your own signature to sign things, right? That means you are supposed to use your own private key to sign. And then to verify, verification means that everybody who wants to verify your signature should be able to verify. That means everybody, the key that is available to everybody is a public key. So that's why, that is a reason why in verifying, we are using a public key, all right? So when you compute signature raised to the power E and modulus N, and then you get back the hash of M because that was what we use when signing. All right, so that is signing in. The second one here is you will later see that it is used as part of the verification process, and we will talk about this in the next video. That's it for now. Thank you very much.